Hey, this is Mrs. Kreider with just a quick review of the two kinds of special right triangles that you have learned so far. First, let's go ahead and go over the 45, 45, 90. You've seen this before. You went over this the Friday before Thanksgiving break, and we touched on it a little bit yesterday. Basically, the rule is if you can recognize that a triangle matches the description where the three angles are 45, 45, and 90 degrees, then we always know that the hypotenuse is the square root of 2 times the length of each leg. Okay, so what that looks like on a pattern is if we have a triangle where the angles are both 45, and that can be noted with congruent angle markings or congruent tick markings. Either one of those will let you know that if you've got a right angle and those markings, then you've got a 45, 45, 90. It's just a right isosceles triangle. That's always going to be a 45, 45, 90. So once we know the leg length, we can just multiply that by the square root of 2 to know the hypotenuse. This is super helpful when we are solving for problems where we don't have all the information, and it's actually easier to do this than it is to solve using the Pythagorean theorem, which is always our fallback method. So the rule looks like this. The hypotenuse, which is always our longest side, hypotenuse, is equal to the leg times the square root of 2. The leg is x, okay, the leg is x, and so we have x times the square root of 2 as the length of our hypotenuse. That's all it is. It's real simple. We've got another one, the 30, 60, 90 triangle theorem, and don't pay attention to these theorem numbers. That's from a different text. So we're just, in these examples as well, we're just going to look at the theorems themselves. Again, if we have a 30, 60, 90 triangle, the hypotenuse will be twice as long as the shorter leg, and the longer leg 3 times, or the square root of 3 times as long as the shorter leg. That looks like a lot of writing, but once we see it in a diagram, I think it's lots easier to understand. So let's move this one up. We're going to put it right on top. Okay, if it's a 30, 60, 90 triangle, and we'll go over here and erase what we drew on top before. Okay, and we'll start fresh. If it's a 30, 60, 90 triangle, the hypotenuse, which is always that longest side across from our right angle, the hypotenuse is twice, 2 times as long as the shorter leg. So the hypotenuse is 2 times as long as the shorter leg. Now you might be looking at this and thinking, how do I know that's the shorter leg? In a triangle, we always can rank the sides the way they by size according to the angles that they're across from. So since that leg is across from the smallest angle, it has to be the shortest in length. The 60 is the middle one, the longer of the two legs, and it's shorter than the hypotenuse, but it's of the two legs, we've got the short leg and the long leg. Okay, so that's what I call them, short leg and long leg. So we know that the short leg and the hypotenuse are connected. The short leg is half the hypotenuse, or other way around, the hypotenuse is 2 times the short leg. The tricky one is the one with the radical 3. If we know the length of the short leg, we can just multiply it by the square root of 3 to get the length of the long leg. We can even use the hypotenuse. If we know the hypotenuse, we can cut it in half and multiply that by the square root of 3. That's a quick summary of the special right triangles. Now let's go through a couple of examples. So here's the first one. We want to find the missing side lengths. I'm going to give you a moment, so pause the recording here and take 2 minutes in class to see if you can work this out. And then when I come back, we're going to work it out together. Okay, so hopefully you've paused this video and you've worked out this example. We're going to go ahead and work it out ourselves. The first thing we want to do is ask ourselves, are we looking at a special right triangle? We know that it is a right triangle. Okay, so that's part of the battle. And then we have legs that are congruent. Hopefully you looked at that and said, hey, wait a minute. Those legs are congruent, which means this is a 45, 45, 90. And if the 45, 45, 90 has legs of some value, then we multiply the hypotenuse times the square root of 2. So if the leg equals 6, okay, then the hypotenuse is going to be equal to 6 times the square root of 2. And that's it. So our answer is x equals 6 times the square root of 2. Now, could you have used the Pythagorean theorem as a fallback in case you didn't remember this rule? Absolutely. You sure could have. You would have just simply set up 6 squared plus 6 squared equals x squared and then solved for x. But you have to give that in simplest radical form, and that's a sticking point. So it's quicker and easier to learn the patterns. Okay, and that pattern comes from this answer though. Okay, that's it for that example. Let's go to the next one. Find the missing side lengths. Again, I want you to pause the recording and take 2 minutes to work through this example in class. And then when I come back, we're going to go over this example again. Okay, we're back, and hopefully you paused the recording and had a chance to work out the question. So now we're going to go through and work out the answer. I see that this is a right triangle with a 30-degree angle, and I know that that means this angle has to be 60. Okay, because if this is 90 and this is 30, that's 120, and that leaves 60 for this remaining angle. This side length that is 14 is across from the hypotenuse. So that makes it it's across from the right angle, which makes it the hypotenuse. So if we know that the hypotenuse is 14, then the short leg, okay, which is across from the 30-degree angle, the short leg is half the hypotenuse. So our short leg equals 1/2 of the hypotenuse, which is 14. So our short leg equals 7. Which is what x is. So x equals 7. Okay, and that's it. We're done with this problem. If we wanted to, we could find the long leg here by simply noting that the long leg is the length of the short leg. So the long leg is equal to the short leg times the square root of 3. Okay, that's it for that problem. Okay, we've got a couple more examples we'll work through. This one's a little trickier. I'll give you a couple minutes on the clock to work through this, and then when I come back, we'll work it out together. Okay, I'm back, and what we have here is another triangle that we can quickly recognize is going to be a special right triangle because we see that 60-degree angle. If that angle is 60, then that means this one is 30. And if that angle is 30, then that means this is our short leg. Now this one's a little trickier because we are looking for the hypotenuse. So right now we have the short leg, okay, equals 8 times the square root of 3. And we have the hypotenuse is x. And that's what we're trying to solve for. Well, we know there's a connection between the short leg and the hypotenuse. We know that the short leg is always equal to 1/2 the hypotenuse, okay? Or we can write that the hypotenuse, or 2 times the hypotenuse, equals the short leg. So we're looking at that relationship, and that's how we're going to solve this. So we can also write that the hypotenuse, we're going to write the other way, equals 2 times the short leg. That's the one we're going to use because we actually want to solve for the hypotenuse. And I'm going to substitute in the values from the drawing right underneath here. We know the hypotenuse is x. Whoops. We know the hypotenuse is x. So I'm going to replace that with an x. We know that it's 2 times the short leg, and we know the short leg is 8 times the square root of 3. So when I'm working with radicals, I can simply multiply. I have 8 square roots of 3, and I'm going to double that, which means I'm going to have 16 square roots of 3. So x equals 16 times the square root of 3. And that's what I'm going to write here. 16 times the square root of 3. And that's it for that one. Okay, this is our, well, we've got a couple more to look at after this one, but we've got one more to find the missing side lengths. We'll summarize after this. So I'm going to pause. You've got 2 minutes. See what you can do, and then we'll come back and go over it together. Okay, I'm back. What kind of triangle did you determine this to be? Another 30, 60, 90 special right triangle, hopefully. There's our 60-degree angle. We know that the hypotenuse is 15, and we are finding the short side and the long side. So the short leg and the long leg. Now, we know that the short leg is half of the hypotenuse. So they're tricking us and we're getting a fraction in here. So if the short leg, okay, if the short leg equals 2, oops, I'm saying that wrong. Forgive. Let's try that again. If the short leg, or 2 times the short leg equals the hypotenuse, hypotenuse equals 2 times the short leg, then we can go ahead and substitute in. Start with the relationship, substitute in the values from the drawing. 15 is our hypotenuse. 15 equals 2 times the short leg. Okay, if we want the short leg by itself, then we're just going to divide both sides by 2. That's how we undo what's being done. That's going to give us a decimal. Okay, 7.5 equals, and look, that's going to cancel, and we're left with just the short leg. So the short leg is half the hypotenuse, and that's going to be 7.5. Now, the long leg is simply the short leg, that's supposed to be an L, the short leg times the square root of 3. So all we have to do here is substitute in our 7.5 and multiply that times the square root of 3. Now, we would likely give this in fraction form instead of in decimal times radical form. So we would really want to write this as 15 over 2 times the square root of 3, which would really just become, and I'm going to write it over here, 15 radical 3 over 2. That would be the appropriate way to see that answer. Okay, so that's it for that one. Let's go to our little summary. We just want to really quickly remember that in a 45-45-90 triangle, and this is the pattern right here that you're going to see. If this pops up on the EOC exam, this is what it'll look like, something like this, where you have to recognize that the side lengths are the legs, X is the legs, and then it's just multiplied times the square root of 2. And then when we look at the 30-60-90, let me bring that up so you can see it, you're going to see the same type of pattern, where once you know the short leg is going to be X, the long leg, the hypotenuse is going to be 2X, double the short leg, and then the long leg is just going to be the short leg times the square root of 3. Okay, so learning how to interpret these patterns is going to be key for you. Okay, and that is it. You are done. We will get some homework for you on Edmodo so that you can practice. In the meantime, keep your notes. Just keep going back over these problems and have an awesome day.